Okay, you see the slides, right? I share it. Okay. Uh, Now you remember last time we talked about DC switch mode DC power supply, and we started with the first type, which is the flyback. Flyback is just improvement happened to book boost converter. So it's book boost converter. Just we improve it by using oscillating transformer, high frequency transformer. Now I have here few problems on flyback today, and we continue inshallah tomorrow. A flyback converter has, I'm reading the question, has the following circuit parameters. VD, which is input voltage, turn ratio is given to me also, magnetizing inductance is given to me, filter capacitor also given to me, frequency and output voltage and output resistance. So I can find output current definitely. He asked me to find the required duty ratio. Regarding to the ratio D, it means. Okay. Now I know that for book boost, D V out, the ratio over VD equal D over 1 minus D, where the D alone is the book effect, 1 over 1 minus D is the boost effect, and multiply it by N2 over N1 will give me the flyback duty cycle. Now, what I want to find is D. I have VO, is given in the question. I have VD, also here VD as you can see, is given in the question. N1 and N2 to N1 is given to me. Where is it? Here, 1 here. So it means 1 over 3, as you can see here. I substituted their values, okay, and I solve for D. I got D, which is equal 0.385. This is D. So the first part is easy and direct, we got it. Now next, he asked me to find the maximum, ripple, average, and minimum value of the current in LM. Now just to remind you, the current for LM is increasing, decreasing, charging, or let me say storing energy, releasing energy. This is the current IL. Okay. Now here is I maximum, and here is I minimum, and here supposed to be I average, and from this point to this point is delta I, mean the ripple in voltage. So let me first find I maximum because I have formula for it, which contain ratio 1 over 1 minus the I output. I can find it from here. I output is equal V output over R output. Again, the ratio D I just calculated. LM is given in the question. T, I can't find it because it's 1 over Fs, and F is given 40 kilo. Okay. So I substituted everything here. I did the calculation. I got maximum current. So maximum current here is equal to 0.772 amp. Now for ripple, we know that from principle V equal L di over dt, or another way, di over dt equal V over L. I have L, but di over dt, it means rate of change between 2 points. So since in our discussion, most of the time we assume that the current increase linearly, it's supposed to increase with a curve and reduce with a curve. But what happened is we assume it's increase linearly in this way. So we can make it in this way, delta I, delta IT. I want delta I, as you know. Delta T is at the end is DTS. I calculated the TS, I calculated because I have FS. So I use, you can see here, delta I over delta T, which is DTS, equal the voltage across the inductance times divided by the inductance value. So cross multiply, I have VD which is 24 given the question. D I already calculated, which is 0.385. TS is 1 over Fs, which means 1 over 40 kilo. LM is given in the question, which is 500 micro. I did the math. I got the value here, as you can see here. Don't forget, this is from here to here, from maximum to minimum, delta I. Okay, I got it. Now, average current here in the middle, it means maximum current, which is this value, minus the distance here, which is delta I over 2, as you can see here. So I got the average value. What about the minimum? If I subtract delta I from maximum current, I got the minimum. Now, is this clear? The maximum, minimum, average, ripple, current? Clear, right? Great. Now, for the last, let me back what he wants me to do. I completed section B. Last part is section C, which talk about output voltage ripple. Output voltage ripple. This is buck-boost converter. We have formula for ripple, voltage ripple, which say, we study this in DC-DC converter. Delta VO over VO equal D TS over ROC. Already I calculated D and TS. RO is given the question, C is given the question. I just substituted. I got this value, multiply by 100%, it gives me 0.96%, which is good. I mean, it's good converter because the ripple is lower than 1%, which means this is good converter. Is this clear? Do you have any question on this part before I go for the next question? Clear? Great, great. Now let's go for the second question, second problem. He say here in a regulated flyback converter. Directly when I read the flyback, I remember this is buck-boost converter. Everything applied there is applied here. Just we have extra, rather than inductance, normal inductance, we have a high frequency transformer. Okay, a little bit improvement occurred in the formula, especially D. With the turn ratio, with the 1-to-1 turn ratio, so already he mentioned that N2 to N1 or N1 to N2 is 1. Done. It means there is no effect here. Okay. In effect on the formula, or let me say effect on the values. Output voltage is 12 volt. And he told me that input voltage is between 12 to 24. Directly when he gave me range, as I discussed before in DC-DC converter, we have two values for D now. We need to consider two values for D. Value which is here 12 and for the value which is 24. The same thing for output power. He gave me 6 to 16. And also the switching frequency, he gave the frequency here 200 kilohertz. Calculate the maximum value of the magnetizing inductance current LM. Okay. That can be used if the converters is always required to operate in a complete demagnetization, which is equivalent to discontinuous conduction mode. Oh, he asked me that make sure that it's work in discontinuous conduction mode. Okay. At the end, this is buck-boost converter. I need to find I/O boundary. Okay. And I output should be less than this boundary. We solve similar problem in DC-DC converter. Now I will come. Don't forget that V out over VD equal N1 over N2. Okay, then I will assume since they are 1-to-1, there is no need to write them directly. D over 1 minus D. Now cross multiply, it will be VO minus VOD equal VDD. Okay, I will take this to the other side. It will be VO equal, I will take D as a common, VO plus VD, and then I divide by VO, it we got here. Now, VO is given in the question, but VD, as you can see here, two values. So I will find D at 12 volt input voltage. It's found to be 0.5. And at 24, it's found to be 0.3 4. I got D now. Now, if you remember, we discussed this in book boost converter. We say that at low, the curve at that time here, okay, we said that we got discontinuity at low duty cycle. So the lower duty cycle is 0.38, not 0.5. Okay, so I will come to find the output current, and don't forget that maximum power, maximum current is the maximum power here, 60 over the 12 volt output. Okay, so it gives me 5 amp. Now, IO boundary, this formula is available in the DC-DC converter book boost. CS VO over 2LM 1 minus D square. So I have everything. I substituted, I found the inductance. Okay, this is the inductance. Now I stop here. There is another problems to be solved in the next session. Do you have any question on the flyback? We can see there is some sort of similarity between a flyback, the discussion in the flyback converter with the book boost, because the same one, just we change the inductance rather than its normal inductance, high frequency transformer. Okay. Do you have a question before I leave?